Hello, everyone. I hope you're doing well, having a great day. Today, we'll be going over L'Hopital's rule. It's a simple concept in calculus that helps you evaluate the limits of certain functions. So, before we get into that rule, what is a limit? So, a limit helps us describe the behavior of a function uh, as its input or, x values approach a particular value. So, that's still pretty scientific. Let's simplify it a little. So let's show a limit to help us explain to help explain this. So the limit of a function f of x. So function f of x as x approaches c, a particular value c, equals, and we evaluate that as whatever it is. So that's the form of the limit. So here's a graph f of x, the graph of f of x, and the limit of f of x as x approaches the c value is L. So um, at this point, x equals c, the value is L. So this describes the function. So as the function gets closer to c, the function will equal L. So to solve a limit, let's say we wanted to solve the limit of x squared as x approaches 4, all we have to do is plug in that 4. So 4 squared is 16. So the limit of x squared as x approaches 4 is 16. So we'll try another. Let's say we wanted to find the limit of 3 of x as x approaches 2. So we would plug in that 2, 2, and we would get 6. So that's how we evaluate that limit. We just plug in. But what happens if we don't get an answer when we plug in? So for example, let's say we had the limit of x plus 2 over, here, I'll write it neater. So x plus 2 over x squared plus 3x plus 2 as x approaches negative 2. So let's plug in. So when we plug in, we get negative 2 plus 2 over negative 2 squared plus 3 times negative 2 plus 2. That equals, so negative 2 plus 2 is 0, over negative 2 squared is 4, plus 3 times negative 2 is negative 6, plus 2. So 4 plus 2 is 6. 6 plus negative 6 is 0. So we get 0 over 0. And 0 over 0 is it's known as an indeterminate form. It's unsolvable. So examples of indeterminate forms are 0 over 0, infinity over infinity, and infinity minus infinity. These are some examples. And when we get an indeterminate form and evaluate when plugging in for a limit, we need to use L'Hopital's rule. So what is L'Hopital's rule? So L'Hopital's rule says that if the limit of a function f of x as it approaches some value c, so limit of f of x over g of x as it approaches some value c, if that is indeterminate, then that limit of f of x over g of x as it approaches c is equal to the limit of f prime of x, so the derivative of the numerator, over the derivative of the denominator, over g prime of x as x approaches c. So let's use that example from above. So that example was the limit as x approaches negative 2 of x plus 2 over x squared plus 3x plus 2. So we plugged in negative 2 and we got 0 over 0. So what we want to do is take the derivative of the numerator. So derivative of x plus 2 is just 1. So the derivative of the numerator is 1. Sorry, limit of x over negative 2. So the derivative of the numerator is 1 over the derivative of the denominator, which is x squared plus 3x plus 2. So that equals 2x plus 3. So we put that down here. So the same limit here, just the derivative of numerator over derivative of the denominator. And then we solve it like a limit. So we just plug in. So when plugging in, we get 1 over 2 times negative 2 plus 3. So 2 times negative 2 is, sorry, this should be that. 2 times negative 2 is negative 4, and plus 3 is negative 1. So 1 over negative 1 is just negative 1. So that's using L'Hopital's rule. Let's go over another example. So let's say we wanted to find the limit as x approaches 0 of x squared over cosine x minus 1. So first thing you do, plug in. It's always the first thing you do. So 0 squared over cosine 0 minus 1. 0 squared is 0. Cosine of 0 is 1. 1 minus 1 is 0 over 0. Uh-oh, indeterminate. So we use L'Hopital's rule. So the limit of this equals the derivative of the top. So derivative, write it down here, of x squared is equal to 2x. So is equal to the limit as x approaches 0 of derivative of numerator 2x over, write it down here too, derivative of the bottom, so cosine x minus 1 equals, so derivative of cosine x is negative sine x, and then minus 1 is 0. So denominator is negative sine x. So then we plug in, and we get 2 times 0 over negative sine of 0. So 2 times 0 is 0 over negative sine of 0. So sine of 0 is 0. So yeah, negative sine of 0 is 0. So we got an indeterminate form again. So we would have to use L'Hopital's rule again. So we have this function right here. And we do limit of 2x over negative sine of x. So that's when we use L'Hopital's rule for the first time. Equals, and then we take the derivative of 2x, the numerator, which is 2. So 2. And the derivative of the denominator, which is, so the derivative of negative sine of x is negative cosine x. Put that in here. So then we plug in 0. So 2 over negative cosine of 0. So 2 over negative cosine of 0. Cosine of 0 is 1, negative 1. So 2 over negative 1, which is equal to negative 2. So in this example, we use L'Hopital's rule twice because we got an indeterminate form twice. So that's an overview of L'Hopital's rule. Remember, the first step is always to plug in that C value. Only if you get an indeterminate form, then you can proceed with using L'Hopital's rule. So thank you for learning with me today, and good luck with your studies.